Good evening, everybody. Welcome to tonight's edition of the Triangle Area SQL Server User Groups Data Science and Business Intelligence meeting. So we have with us TriPass board member Rick Pack, who's going to talk to us about some spatial analysis. So please take it away, Rick.
Thank you, Kevin. It's a pleasure to be here today. I'm going to, as Kevin said, speak about using spatial tools in Alteryx, a rather popular piece of software now. You might check stock AYX, the stock with the symbol AYX, X to see its performance. And also I'm going to be looking at zip code sum versus zip code tabulation areas. So this is going to be a fun presentation, I hope, wide ranging. I'm certainly not an expert in this area or these areas, but I think there are plenty of interesting questions that we can answer more easily now because of advances in computing. And of course, the internet giving us so much information. What you have on screen, let me actually convert this into the actual slideshow, if I can remember how to do that. Wow, I'm blanking. There we go. So while this loads, so at the outset, I am going to say, Elaine requested an analysis of a particular zip code, and there was some discussion in the comments. I decided to move away from that engagement because this was rather time-consuming to produce, and the Alteryx workflows were taking longer than I would like. So just want to set expectations there and indicate, like I said, this is going to be a broader take on these concepts. What you have on screen is a sense of what we're talking about. On the far left is a zip code, and you can see the irregular shape. In fact, this is really a circumscribed shape that doesn't describe what that zip code is. I think this is just a pseudo zip code, because zip codes are composed of postal routes, and so we can do our best to geographically represent those, but it will not be a perfect image with a clear perimeter, at least one that's going to be easily understood. Understood when we look at it. A zip code tabulation area, on the other hand, a ZCTA, is based on census tract blocks and will not cross state lines, will not cross county lines. And so these are much easier to understand, and yet I think we would all agree not nearly as popular in terms of use. So a bit about me. It's after work. I do believe it's important to have some fun with these presentations. So there are fun bits in this image. I have been doing data science, as we now call it, professionally since 2009. I worked in the pharmaceutical industry for about 5 years using SAS before switching to the CDC, at which I used SAS, and also was able to learn R. I also was exposed to R in graduate school. I have a master's degree in applied statistics from Penn State. And I like to stay active. I like to stay busy. I'm in 2 data science organizations, and fortunately, I'm a board member with Kevin, as he mentioned. I am a Google Summer of Code mentor. I've been a mentor. I am a mentor this year, and also was a mentor in 2019. And I forgot to include the link here, but you can see what the team has been producing in this year's Google Summer of Code by going to r-community.org. That's r-community.org. They're using Flex Dashboard, which is an R package, to create what I think are some pretty cool dashboards. And I presented that work just a week or 2 ago at the USAR conference that you see at the bottom right. And yeah, I run in track meets. I actually just ran in a track meet this past weekend. I run in the men 40 to 44 age group. A friend of mine is there. He is in the 35 to 39 age group. We're holding bronze medals. We were 3rd in our respective age groups, and it was very competitive. So I'm quite proud of that. I love the 400 meters.
One quick question, Rick. How do you run in the 40 to 44 group if you're only 28?
Excellent question. So the answer is that Kevin is a flatterer. So those of us that have learned how to connect with others through flattery find that people like us more. No. But anyway, look at these gray hairs. In fact, I'm very tempted to put on the hat I'm wearing. So this is, anyway, I need a haircut. Okay, so enough of that. Oh, this 100 black men, I'm a mentor. That's what that 3rd bullet is, a mentor youth. So I've already talked about zip codes and ZCTAs. The ZCTA is a trademark of the U.S. Census Bureau, whereas the zip code was invented by the U.S. Postal Service. the ZCTA was actually second. Zip codes came first, and then the Census Bureau did its best to kind of geographically create spaces around those. And so, like we said, there's going to be some misalignments there, and zip codes can cross county and state lines. The zip codes are really aligned with carrier routes, and I think this bottom bullet is one of the most important ones on screen, or bottom idea. 15 carrier routes per zip code, so you can imagine the geographic complexity. And a next door neighbors could, in theory, and I think I saw this somewhere, forgive me, but they could have different zip codes, so it's hard to represent these spaces geographically. Census blocks are geographically easy to understand. They are the smallest level of geography that the Census Bureau uses to provide data. So my interest in zip codes and zip code tabulation areas came from, it stemmed from my analysis at work, looking at geographic spaces and attempting to understand elements related to the demographics of those spaces. The data that I'll say often have are in zip code, are based on zip codes. And when merging data sets, I found myself dealing with missing values unexpectedly. And it was because you cannot associate a population with some zip codes. Zip code tabulation areas, if there's any data to report for those, then you are going to have a population. If there's any demographic data, then you're going to have some population associated with that space. But at the zip code level, well, some sources are going to have some kind of demographics data broadly defined, and others not. In Alteryx, if a zip code is associated with a PO box or a hospital, for example, these are, I'm forgetting the phrase right now, large centers, let's say. So hospitals can have their own zip code, prisons can have their own zip codes. These will not actually be associated with a population in some data sources, like the Experian data source I use in Alteryx. I'll talk a little bit about that later. So this presentation came from a desire to really explore what would happen if I took zip codes and mapped the data to ZCTAs. There is not an official zip code to ZCTA crosswalk. My best guess, I could not get a clear answer on this, my best guess is that the reason the census, it would probably be the census, does not take their ZCTAs and give you a crosswalk for the Postal Service's zip codes is because of liability concerns, if I had to guess. It also could just be too complicated. Any kind of crosswalk that we use is going to be imperfect. It's like I said, these routes are winding, so it's geographically very difficult to represent. It's impossible, I imagine, to in a useful way geographically represent all zip codes. However, UDS, what is UDS? Sorry, the Uniform Data System is a source. I am not very knowledgeable about this source, but they do provide a crosswalk in an Excel file that you can use. And they have plenty of warnings like this one, PO box, that's the phrase, and large volume customers such as prisons or hospitals. PO box and large volume customer zip codes may not correspond to residence location of the census population using that zip code. So merging these is problematic, but sometimes necessary. So the other big area for this presentation is that of Random Forrest. What you have on screen is from the Machine Learning Journal in 2001. This author, Leo Bremen, I forget how to pronounce his last name. I think Bremen is an innovator of a very respectable kind. He invented this Random Forest model based on one account I heard in the podcast, on an obsession. He was a statistician obsessed with improving the prediction performance of AdaBoost, and was also very entranced with the easy to interpret output from decision trees. But decision trees are infamous for overtraining, and so he came up with a method of using random sampling. We'll get into that a little bit more later. Well, actually, sorry, I have it on screen. So imagine you have a lot of different predictors, and I'll ground this in something concrete in a few minutes. If you have a bunch of predictors, if you randomly select from those predictors in a sensible way, create decision trees, and if you do not know what a decision tree is, and we'll get to that later, and then have an algorithm that's able to, based on the outcome variable, and I'm certainly not an expert on this, but if you can, based on the outcome variable, the response variable, correctly associate the correct trees, you can aggregate that performance and use essentially a bunch of uncorrelated decision trees to make predictions that are surprisingly accurate relative to other methods. It's interesting because in the article, decision tree only appears in the bibliography. Instead, we only see the word tree used. So this was at least an interesting lesson for me. In the statistics world, I now know when I see tree to think decision tree. Another cool feature, to use a word I probably shouldn't, about Random Forest is that we get, because of its algorithm, some measures, a measure of variable importance. So if you have a bunch of predictors for randomly sampling and generating all these trees, and when I say you, I really mean Mr. Brayman's algorithm, you're then able to, through all that complicated aggregation and random sampling, still get a very clear indication of variable importance, and we'll show that later. So about Random Forest, like I said, Brayman was obsessed with AdaBoost. He wanted to improve this boosting method of prediction. What he says in the article is that its accuracy is as good and sometimes better. But he also highlights it's relatively robust to outliers and noise. It's faster than bagging or boosting. So when I saw this bagging, I became curious because in researching Random Forest, it seemed like Random Forest used bagging. In fact, I believe some sources indicated just as much. So we'll come back to that in a little bit. Random Forest is actually pretty fast because it can run, unlike decision trees, it can run trees in parallel. So it can take advantage of the multiple processors we have available on our computers today. So when I think about his comparison, having not studied the article thoroughly, when I think about his comparison of Random Forest to bagging and boosting, I think part of the comparison he's doing is a contrast of the computing methods used. So Random Forest, because of the parallel processing, is going to be advantageous, so obviously, over those methods that do not use parallel processing, at least in terms of speed. And so we've talked about this. Yeah, so that last one, simple and easily parallelized. So Brayman compared Random Forest favorably to bagging and boosting. Well, what are those? Well, in the artificial intelligence world, we're using learners to improve a model, and essentially these are ensemble techniques. So we're going to take the learners and make a better learner. That's the learning. That's the artificial intelligence. And that learning improves. Sometimes the focus is on reducing error so that you ultimately get a better model as the algorithm iterates, creating a better predictive model. Bagging is random sampling with replacement. Boosting weights data based on performance, and but still includes that random sampling with replacement. The interesting thing then is what Random Forest is able to do is take the feature space, all these predictors, and divide them algorithmically based on those response variables, like I said, based on the outcome at the bottom of the trees. And I mean, to me at this point, this is something like magic. I might do another presentation to understand this better. But that random selection of variables and that linking, that association of trees, and there are lots of trees, ends up creating strong performance. By trees, I am speaking about decision trees. This is an example from displayr.com. And so you can follow a line. We'll pick one in case anyone's not familiar with the decision tree. So we start at the top, and the question is, what is the weather? There are three options. Say it's sunny. That takes us to the left. What time is it? How long has the sun been out? I think. What is this? I'm not sure. So you can tell I haven't studied this diagram. If the sun has been out for more than 30 minutes walk, that doesn't seem right. I'm not sure what that is. So anyway, having not understood this diagram, I'm caught. But you can imagine that if each prompt was easily understood, you would eventually get to an outcome. If you built lots and lots of these trees based on different cutoffs, we're using a continuous variable for this presentation. It's going to be the population of zip codes or zip code tabulation areas. Hold on to your seats, we'll get to that. Then you could, the random forest model will average across a bunch of trees, taking into account the variables used and the splits used, and give you predictions based on each record's values on those predictors. There was a presentation that I found on Kevin Fiesel's YouTube page that helps to explain why this is machine learning. And I guess what I just wanted to highlight here, first I wanted to invite you to check out Kevin Fiesel's YouTube page, and I give you the particular point at which this image appeared. And the idea is that given a data set, given a training set that gives us the outcome, it's going to tell us per row whether or not, in this case, it's a cup or not. You can have a model that can then respond to new observations, your validation data set or your full data set. And a well-performing algorithm will do a good job of predicting whether or not, based on these inputs, these features, I'm using those synonymously, whether or not the top is open or there's a cap on it, a closed bottom, what that object is. And you can also sometimes get measures of certainty. So the learning, again, is because of these iterations that are taking place algorithmically to test predictions and against what's actually true, and then eventually give a prediction, hopefully, of which we're confident, a single prediction based on the aggregation and learning that has taken place over all those iterations. So this is a segment of the Alteryx workflow that I used for this presentation. So it's presented on an Alteryx canvas, aka a screen. So you're looking at an Alteryx canvas. I could not, let's say for professional reasons, I could not show you Alteryx live today. But on the canvas, we see different circles and rectangles and similar shapes. These are tools in the Alteryx world. What I wanted to show, the red line's already on screen. So processing proceeds left to right. So data comes in on the left and it pushes to the right. Now, this can get confusing because these tools, this is a GUI, so you can click and drag these around. I could move any of these tools to the left, and one would just need to understand that arrow to be moving to the right and then potentially around, depending on where that right tool is moved. Be that as it may, there are different allocate tools in the Alteryx world. So whether we're talking about zip codes or other geographic units, the allocate tools allow us to identify demographic data within each of those geographic units, so within each zip code. The input tool appears here. You will notice that nothing appears to its left. So it is its own input, allocate input. So you would go in the tool, I'll show that later, indicate your geographic unit and what variables you want, what demographic information you want, and then that data would proceed forward on the workflow. The Append tool is different. So what the Append tool is doing here, at the bottom left, what I'm doing is actually allocating to a zip code tabulation area the demographic variables that I referenced a moment ago. So the Allocate Append tool can take data as an input that will then display those values for the geographic units in which we have data. I'll show that a little bit better on the next screen. So, oh no, it's not this screen. Okay, so let me talk about this just a second. So inside of the Allocate Input tool, one would specify the geographic unit. Inside of the Allocate Append tool, and by inside I'm referring to configuration, you would indicate the variable containing that geographic row identifier, like the particular zip code 40241, that's coming from the input data set. That's all. So in both tools, Allocate Input, Allocate Append, you are going to get variables when you select them. While the text is readable within the tool, the data that comes out is not readable. Instead, you get these CYC values that you see here. These are, I don't know why that is the case. But I do know, because of training that I experienced from Alteryx, they do have a nice training staff. I will say, anytime I use the allocate tools, I need to use dynamic rename tools. So the dynamic rename here takes from something called an allocate meta info. I'm just telling you, of course, there's no need to remember all this. And it converts those variable names, those identifiers into easily read text. In this case, you see US 2019 white, US 2019 total population. This is also an opportunity to highlight that anytime in this presentation, I'm not sure if I caught all of these, you see 2019 references, we're actually referring to 2020 data. One of the things about working in the Alteryx world, this is not a presentation meant to advertise for Alteryx, even though I am a fan. I do want to highlight some concerns. And so one challenge when working in the Alteryx world, if I'm reusing a workflow, but I change certain elements, it's more cumbersome than it would be as a programmer to change downstream elements. So in this case, the reason why I have 2019 here is because some of the tools that you see on this screen, like 2019 up at the top right, were copied from a previous workflow, and I do not want to have to go into each tool and change all references to 2019 to 2020. As far as I know, there's not, even in the current Alteryx version, a find and replace that would go inside all the tools and change their configurations. Connor can correct me if I'm wrong. It just hit me that there might be a newer feature, but I don't think so. So that is a challenge when dealing in the Alteryx world, but there are tools to make this easier, such as this dynamic rename tool that can formulaically, through a regular expression or just a regular text replace, change my 2020 references in the latest data to these 2019, to the 2019 identifier, so that all my other tools copied from another workflow will work as needed. The reason, by the way, these formula workflows that you see with the red arrow are being used is because out of the allocate tools are going to be the number of individuals in about 10 to 25K income blocks. And I wanted to instead identify the household income per zip code or zip code tabulation area that was below or above certain thresholds, like 50K. So I'm adding from 0 to 10, 10 to 20, something like that, adding those to get the total number of households, say less than 50K, and then dividing that number by the total number of households to get the proportion that are of different income blocks. Oh, this isn't, so forgive me, I forgot I had this. So this is what I was referring to earlier. So inside of the allocate tool, this is actually going to be an allocate append. I know this is an allocate append because of this key field option, I guess, that you see in the center. That key field, that's why I said option, that key field is allowing me to indicate what in the input data set has what the allocate tool will treat as, what you see on the left, zip codes. There are many options here. You could have from your input data set census tracts, as you can see, designated market areas. If you're a geospatial data geek like me, this is just amazing. There are so many ideas that come to mind, especially as you think about different data sources you might have and you would like to append an enormous amount of data made available by Alteryx if you pay for its data packages in particular. I think the location, I can't remember what comes with base Alteryx. I feel very fortunate at work to be able to use the, it's sometimes called business insights. There's another name, I'll get to that in a second. But the business data package that gives me so many variables. You can see on the bottom right, there are Simmons product profiles variables. The basic variables are the ones I'll focus on today. Those are like the Hispanic or ethno-racial populations, income, household income populations, rural or urban numbers. So those are the basic variables. Consumer expenditure is available. How much are individuals spending on healthcare, various forms of entertainment, frozen food. the possibilities are absolutely amazing. The same for occupation and employment. Where are people working? How far do they travel to work? There's so many variables. It's amazing that you can add on, and then you can use predictive modeling to try and predict certain outcomes. In this case, for today, we're going to be predicting total population as a toy example. We obviously already have that population, but you can imagine if you had marketing data on certain areas and you wanted to know how that marketing would perform in other areas, you could append so many fields and then make predictions about how that marketing would perform elsewhere. It's just amazing. So these are variables that you see on the right. These are drop-down menus, and then in that drop-down menu, you would have the items I identified, like how much money individuals spent on fast food. Like I said, this is a slide. So unfortunately, what I'm going to be showing today, actually, I'm using basic variables today, forgive me. I might be able to in the future, depending on certain barriers, be able to show some uses of the consumer intelligence data, aka business insights. These are the many variables that appeared at the bottom right on the prior slide. But I wanted to highlight here, this is an expensive opportunity. So depending on one's use. So I just wanted to highlight that. Location intelligence, so I'm blanking at the moment. Location intelligence gives you the spatial tools. It may give you census data, which is free. Using the, let me think about it. But anyway, you could get the census data anyway and use some finagling to make it work within the Alteryx world. So I'm pretty sure the census data are provided. But like I showed earlier, I'm showing 2019, actually 2020 estimates in this presentation. So that's using the Experian data made available also through that consumer intelligence data package. So this concretizes things a little bit. I'm zooming in on certain elements from the workflow. What you see in the blocks containing numbers are really results after running the workflow. And so this just talks a little bit about what I had to do in order to get today's presentation to come into form. I have zip codes. I have zip code segments of, okay, a zip code segment of workflow on the top, a ZCTA segment of workflow on the bottom, and I'm bringing those together in a union tool, a row-wise concatenation union in the SQL world, a union tool, and then I'm transposing so that I have each variable, remember back here I mentioned variables, each variable like the proportion of the population that is black on a row as well as its geography and that value. And then I join those together on the variable and I'm able to compare the ZCTA value to the zip value to try and get a sense of the impact of using the ZCTA. What I may not have made clear earlier is that a question has been, is it worth taking that zip to ZCTA, very much unofficial, warning expressing crosswalk, and convert zip codes to ZCTAs? That's an outstanding question that I'm exploring some today. This did not work right. Oh my gosh. So I want to apologize. This slide is not working well at all. But the point here was that there are lots and lots of variables like percent political, $200 or more. So how many households, what is the percentage of households that spent more than $200 on political material? So many variables, but I think I made that clear enough. And my apology for not doing that right. Wow. So like I said, using the transpose and then a join, I was able to put on one row the variable. Again, these are 2019 variables despite the 2019 label. And see what was the impact? Well, across the country, if you take all the data and so I'll do the first row. So urban proportion, if you sum all the individuals, so you get the total population, and place in the numerator the number of individuals that are living in urban households, the census, the census defines each household as being urban or rural based on population density. So it's a binary. What is the proportion per So what is the proportion in the country that is urban versus rural? You can see that if we use the zip codes, then we actually get a more urban proportion in the United States. I think this is because the zip codes are going to take into account, are going to actually miss more individuals in rural areas, which is, I mean, I guess it's intuitive when you look at it, but so one reason this happens is because individuals that are living in sparsely populated areas sometimes do not get mail. I saw that. Sometimes do not, and related to that, do not have zip codes. So I want to dig into that further, but that was still interesting to me, and it caused me to, like I said, think about with analysis questions, how important is it to be, to make sure that I am taking into account those living in sparsely populated areas. In many use cases, I'll say that one may need to, one may not feel a need to focus on sparsely populated areas because of the additional resources that would be needed to reach those individuals. That's an economic decision, of course, recognizing that all people are equal, of course. There's a bit of a mistake here, but you see that the use of ZCTA is associated with a slightly more rural population and even more slightly more white. Just a few more zip codes, about 2% more zip codes in the country than those ZCTAs. Again, ZCTA is zip code tabulation area. The zip code tabulation area is based on census blocks and is a more cleanly identified geographic area. So then I thought, well, what if we just looked at Raleigh, North Carolina to get a sense of this? So going back and then going forward, you see the numbers are quite similar. These negative 0.01, these negative 0.01s and 0.01s are very near, obviously, the zeros that you see. The rows have not changed in sequence unless a mistake has been made. Oh, there's a, no, I think so. 1, 2, 3, 4, 5, greater than 1, 2. There is a mistake. But anyway, so I'll focus on urban proportion. So in Raleigh, North Carolina, if we use zip codes, then we conclude that the Raleigh-Durham, North Carolina designated market area is a bit more urban if we use zip codes than if we use ZCTAs. So again, a zip code has a preference for those living in urban populations. Just something to keep in mind. All the other variables are very similar though, just like what we saw here, except the non-Hispanic white proportion was a little higher for the ZCTA, whereas here, oh, it is higher, sorry. So now we'll talk about doing some predictive work finally with the Random Forest model. So in the Alteryx world, the R package Random Forest, lowercase r, capital F, is implemented in the Forest model tool. Another presentation might look at the different hyperparameters we can set in Alteryx that corresponds to arguments in the functions of the Random Forest package in R. But I do want to say that not all of the hyperparameters are available in Alteryx. On your screen, what I'm doing is so as I talked about earlier, I'm using a ZCTA, zip code tabulation area workflow. Then on the bottom, I have a zip code workflow, and they're going to run separately. And then I'm going to compare performance for predicting their respective populations. Again, as a toy example, we can see the selection of predictor variables here, like household income greater than or equal to $50,000. Number of trees to use. I saw a recommendation to start with about 10 times your predictors, so I chose 100. And there are 9 predictors. So this is fun. I also included a decision tree model, partly to help gain an understanding about how the Random Forest model works, taking into account that the Random Forest model is essentially aggregating a bunch of decision trees in an algorithmically sensible way. One thing I noticed that the mean percent error NPE for the decision tree is 0. This seems to be part of the algorithm's definition. We also see that with the actual population on the x-axis and the predicted population on the Y, lots of variability when we look at the decision tree model, but a pretty strong, actually a very strong correlation with the random forest model. However, this is an example of why it's important to look at other summary statistics when gauging a model. While the correlation is very high for the random forest model, it is doing a very good job of distinguishing zip code tabulation areas that are low in population versus those that are high. The mean absolute percent error is 29%. When looking at the data, this summary, it appears that a lot of that error is favoring the actual side. So it's under predicting population very often. The blue circles are below this line that would indicate perfect prediction. So, you know, that might be a problem, right? If this was a real use case and we needed to predict something and it took our data and the model was off by an average of 29%, that would be a problem. And the root mean squared error was 5,000. So say 5,000 people, that might be important across zip codes as far as a difference relative to the prediction versus the actual population. So this is kind of fun. So like I said, the correlation was high, but that percent error, the mean absolute percent error in particular, again, that was 29% for Random Forest, was higher than would probably be good. It is interesting that the zip code did do a better job when used of explaining the variance, 80%. So again, so zip codes are going to include more people versus zip code tabulation. I don't know if that's true. I don't think I checked that. I'm sorry. There are more zip codes, I'll say that. So that's probably linked to doing a better job of explaining the variability. I haven't explored this more thoroughly. So you have more units that you can then use to make predictions algorithmically, and it ends up making a significant difference here, a very noticeable difference. One thing to look at here, so this is actually from the Alteryx output when using the Forest tool, the Random Forest implemented tool. The error on the y-axis, I'm not sure if you can see this, is much greater for the ZCTA side. So this is just a reminder when looking at this kind of graph to check your axes. This is 8 times 10 to the 7th power for ZCTA, but this is 6 on the zip side. So the error went down much more for zip code, which would align with the higher percentage of variance explained. That setting of 100 for the number of trees appears to have been a good one. The error is pretty much evening out, plateauing around 100. Here's a variable importance plot that we automatically get from the Forest tool. This is for the United States, and we see the rural proportion of a zip code, those households living in less populated areas. That variable is a very high importance for both zip code and zip code tabulation area. Asian proportion was a surprising second. This is an opportunity for me to say that something that disappointed me about the model is that I did not see a way in Alteryx to get a better understanding of how these variables are affecting the prediction. From what I've read, the Random Forest model is sometimes regarded as being black boxy. So it may be that you cannot. It may be that the algorithm is doing so much calculation that when it ultimately is giving you this prediction, this averaging across all these trees like we talked about earlier, it can't actually give you a very nice decision tree like we showed earlier or anything like that. This is the closest that I think it can do. Bremen included variable importance in the algorithm, and so it automatically, so to speak, is able to give you that information. Be that as it may, rural proportion is first in importance, Asian proportion, and then there's some changes between zip code and ZCTA. So I'll just show it that way. So then I looked at Raleigh-Durham to get a sense of, well, what happens if we, instead of looking at the country, focus on one particular area, our local Raleigh-Durham area? Do we also see this better predictive performance when we use zip codes? Now, this is not using all the data in the country. This is inputting into the tool, the Random Forest algorithm, only the information associated with this Raleigh-Durham DMA, which is not very many records, but still I decided to play with it. And here we have rural proportion again first, Asian proportion second for variable importance. But then household income, that's actually 100K or more, that third one. Whereas household income when we looked at the data nationwide appeared at the bottom of variable importance. So still, relative to the top two, that number 3 is not, well, actually it's higher than it is higher than I thought initially. So that household income is apparently more of a distinguisher in our area of population, at least when only looking at our data as modeled by Random Forest, than we see nationwide when modeling the country's data. I suppose this might speak to, so ethno-racial columns are above the household income column. So it may be that nationwide, it's really that simple. The ethno-racial identification better predicts population. Yeah, so that's interesting, right? And you can just imagine doing cross tabs and attempting to understand this more carefully. But a key conclusion is that once again, zip code does a better job of the prediction. We have much more variance, about 20% of the variance between Raleigh-Durham zip codes explained versus that explained for the population in ZCTAs. That 20% greater variance for zip codes was also true nationwide, about 20%. So this is the entire Alteryx workflow I use. And this, again, we're not marketing Alteryx here. I am a fan, but I will say that when the workflows get big like this, there can be some interesting slowdowns. Just so you know, you might move a tool and it takes a while for that to complete. I think that's all I'll say here. I could run through all that's happening here. So I've mentioned the fact that I distinguish between a ZCTA segment of workflow and a zip code. And if you look really closely, the word ZCTA appears here. You can label the connectors in Alteryx, which is quite nice. And so up here, it's labeled ZCTA, and at the bottom here, it is labeled zip. You can also change the identifier under the tool. Each of these, of course, is a tool. You can change the identifier. Some tools will automatically populate a description, I should say, rather than identifier based on what is the configuration of the tool. So in this case, you can't tell, but this is a formula tool, and it is how I derive that black proportion. So I'm taking into account, I'm taking as numerator the number of individuals that are black from the input tool, dividing it by the total population, also from the input tool, and then I'm getting a black proportion tool. That definition of black proportion then appears in an abbreviated way under the tool, which is quite nice. Oh, how did that happen? Sorry. So in conclusion, we have found that zip codes do a better job of predicting population. This was a toy example, but it does cause me in more serious settings to be mindful of what I might be losing by using the crosswalk. However, I'll remind you that many times we can only get data at the zip code level, and so it might make sense. I'm sorry, hold on a second. Oh, okay, sorry, I blanked for a second. Even though we can get a lot of data at the zip code level, we sometimes cannot. So, like I mentioned, in Alteryx, you're not going to get a population for a zip code that is a hospital or a post office box. And so there are nuances to consider for one's particular use case to decide whether to focus on the more, in theory, representative zip code or the zip code tabulation area. What I currently am thinking is that it does make sense to use that crosswalk so that I'm more likely to bring all my data sources together, to not lose data because of lack of information. So that is today's presentation, a little overview of zip codes and zip code tabulation areas. Again, zip codes are provided by the US Postal Service and came first. And then the census came up with the more geographically understandable zip code tabulation areas. We have looked at Alteryx workflows and talked some about the Random Forest model. A description that I liked about Random Forest with respect to bagging, while Bremen did say that his Random Forest model is superior to both bagging and boosting, he also called it, in a 1999 article, a fancier version of bagging. So bagging up all these trees and then giving you a prediction. This is my information. We can connect on Twitter if you're interested. I have a blog as well. And you can feel free to reach out on LinkedIn. Just let me know, please, that you are reaching out because you saw this presentation. Thank you for your attention today. Are there any comments or questions?
Yep, there are plenty of questions here.
Okay.
So the first one, how does Alteryx access the data? Is this in Azure or a public or private cloud?
That's a great question. So I was sent a USB drive. So it is locally, that data is locally acquired. You could use Alteryx server, but still, it's not a cloud data source in the sense that you're saying. Alteryx provides that data it provides that data. If I didn't answer your question, please let me know.
No, I think that answered the question. So could you have data sources be things other than what they provide, or?
Yes. So I wish I could show you Alteryx itself. I would love to be able to afford a personal use. But yes, you could. You can use, this is an input tool. Is this visible, Kevin? Easy to read?
Yeah, Excel file.
Okay. So yes, you could bring in any kind of data. Well, lots of different kinds of data. I have used JSON at work. I've output JSON. You actually can't use JSON as an input from what I've seen. With that, well, yes, you can. I'm remembering all these things. There's a discussion board, community.alteryx.com, community.alteryx.com. And there is a way to take JSON input through some manipulation. And yeah, join this purple, and you can join if you have a key variable on which you can join, or union. That would be dangerous, so forget that, don't do that. So yeah, you could join the data and process it as you like.
Okay, and that answers Raymond's next question about whether data sets are pre-canned or customer loaded. Sounds like the answer is both are possible.
Yes.
Interested in geospatial addresses with good geocoding quality, non-US, for example.
Do not know about non-US. There is I can see it in my mind, a create points tool. Well, there are, wow, I'm seeing all these spatial tools. So I've been doing a lot of spatial work in Alteryx. So there's a cast tool that's a standardized addressing tool that will take addresses and do a better job of putting them into a form that the create points tool will then use to give you a latitude and longitude. You can also go the other way with that and go from latitude and longitude to address, at least within the US. I have not worked with locations outside of the US. So those tools are made available with the location intelligence package, also called Location Insights.
Right. The expensive edition, as opposed to just the really expensive edition versus extremely expensive edition.
Yes, sir.
So for planning or predictive mapping of inventory, parts, stocking, etc. over customer hotspots, how would you design or set up training with Alteryx?
what was the customer hotspots? What was the noun before that?
So
Oh,
the idea would be if you wanted to figure out which spots, which locations, like say which distribution centers I'm going to have the most demand for given parts.
which distribution centers are going to have the most demand for the given parts?
Yeah,
Sounds like
or
an
retail stores, like which of my retail outlets are going to sell this thing.
okay. I'll show you. I hope this works. I'm going to share my screen. If it does not, please let me know. Okay.
I'm seeing Microsoft Word.
Can you say it one more time? I'm sorry.
Yeah, so the idea would be like we have different warehouses or we have different retail stores. Let's go with that. You have different retail stores, and those retail stores are obviously in different physical locations. Now, I have a particular product. Let's say I sell like a sheep shearing tools. Which retail outlets are going to sell the most of these sheep shearing tools?
Okay.
And probably
Oh,
won't have too many of them in downtown stores, but you know.
Yeah. Okay. This is an okay. I feel like someone who is testing whether or not I would be a good candidate for a job is asking this question. So this is complicated. On the spot, I'm not sure how good I'll do with this. So you're going to have as an input data source at least your addresses for these retail stores. You could then use on the left here, I'll put tools. Tools : okay. Then as there's a trade area tool. This is the first thing I would do. So you would set it to some distance. You could do driving distance, say within 10 minutes. At peak, I always use this at peak driving time. There are multiple options. The location insights package gets this driving time data based on TomTom. You may be familiar with the TomTom. I'm not sure how to describe it. GPS, maybe outfit. I used to have a TomTom GPS device in my car. Anyway, with that said, so a trade area around those addresses. Around the addresses, we're then going to use allocate within that space, in the trade area space. So before I used the allocate tools to identify certain zip codes or zip code tabulation areas, you can also do spatial objects, as they're called in the Alteryx world. That trade area that I'm creating here is going to create a spatial object, and you could then identify, gosh, there's so much data if you have that business insights. It has a new name. You saw it in the slide earlier, but if you have that rather expensive data package, there are so many consumer level variables you could add. You might be able to find, actually I've seen this, something like farmers. Now, this is a bit, I would not do a 10-minute drive time if you're talking about farmers. Maybe do 60 minutes drive time. See how many are involved in farming. And then that might enable you to get some kind of estimate of sheep shearing tools. I would then use that as, so then I would convert the number of households with at least one person in farming. So we'll say number of farming households divided by total. And then I would make that a predictor in a prediction model to see how well it performs versus some other data like the total population. Maybe that alone is very predictive. Again, this is not as if within the trade area, right? So the total population, but maybe instead of 60 minutes, if you're looking at total population near a store, maybe you would do, this is actually similar to something I'm doing at work, something similar, something different, pardon me, like 15 minutes, because what you're attempting to speak to is who is going to be likely to drive to this store. And if we take the total population near the store, then that might be more interesting than the total population in a broader picture, even though the target for the prediction is sheep shearing tools. You know, it would just take some iteration and experimentation to see how these kind of counterbalance each other out in a well-performing algorithm if one can be identified. So anyway, that's the kind of thing that I would do. I would need to look at all the variables available to do this in a more helpful way. If I did not answer the question, please let me know.
No, that's fair. We are putting you on the spot for this, after all. I did link to a user group meeting for TriPass that Alice Broadhead did back in 2019, if I remember right, where it was predictive analysis using Alteryx as well. So check that out, folks in chat. Let me go to the next question, which is also in the form of 12 questions. Okay.
I'm not sure if that means the presentation was good or not. Okay.
No, it worked well. You inspired questions.
I love it. No, I really do love it. Please do ask that.
Is there a way that Alteryx develop, like model building and runtime, can be used outside of a business intelligence user experience? So, for example, can I build a model using Alteryx and maybe deploy it to a server or deploy it to some other location, have it execute?
Yeah. So, as I'm sharing my screen fully, please ignore the fact I have 8,000 windows open.
And that you have to update.
Good point. So Alteryx has a deploy tool. I have not used these tools. We do have Alteryx server at work, but I am not yet using it. Oh, you do not need server to use deploy. So anyway, I think rather than ramble, I should just invite exploration of this tool and related links to see how you might do what you described, extending the model out into these other domains, as I understood you.
Okay. And does Alteryx require internet access for their software to add value to the models? Or let me rephrase that. Is there an offline mode, or maybe can I run this thing behind in a subnet which isn't allowed to access the internet?
The thing I do not know is whether Alteryx is going. I think the problem is going to be. I know the problem is going to be confirmation of your license. And Kevin, you may know the technical term for that. I know they confirm that one has a license. You can download the software, but using it requires activating a license.
Right, and most likely, if you're in a scenario, Mike, where you would want to lock that down so much, you'd probably whitelist the license server IP address and say, okay, well, you can go and communicate with this server, this IP address, and do your licensing stuff, but then everything else locked down.
Yeah, and I'm sure there is a solution for that. Yeah, I'm sure that there's a solution because Alteryx is a big player. Their revenue is something like 400 million, I think. So they have, there we go, 500 million. So yeah, they are dealing with some large enterprises and surely will have someone that would want to help and likely would be able to help with this kind of challenge.
Right, and they had a license server there, so you could have the license server set up within your network, and that server can access the outbound IP address for whatever licensing system that they have on their side, and then your execution servers could be completely blocked off from outbound internet traffic. Probably. I'm just spitballing it, but that's what it looks like based off of reading the titles from Google searches, which makes me an expert on the product.
Sound like one.
Elaine found out in replying to your request for zip code examples that she owns land in California that does not have a zip code associated with it. Yeah,
so you may have caught earlier, I blanked on whether every person is in a ZCTA. I know that there are people that are living in places, better stated, there are locations in the United States that are not associated with the zip code. So even though the census started with the USPS zip codes to create the ZCTAs. I think ZCTAs contain more people. I'm not sure. So that is something that I'll check after this talk.
Okay. And Mark mentions that zip codes were created in 1963. So we got that going for us.
Thank you, Mark.
Can we zoom to the URL on-prem license server? You know what, Raymond, I can copy paste that URL for you. That's one of the many bonus features that you get from tuning in. Also, you get to hear me clacking on my keyboard because I didn't mute it correctly. So, all right, while I'm copying and pasting, if anybody has any other questions, that's the link to the deploy tool. And if anyone has any other questions, now would be a wonderful time to ask them.
It's very confusing. A ZCTA may not exist for every zip code. It's very confusing. Some of you may have also seen zip codes can change. They can change over time. Yeah. This is not true. They do not change. Well, I guess as a whole, you could say they change in the sense that one or more zip code changes every year. Anyway, thank you for that digression.
Of course, it looks like that was the last question. This was really cool. Thanks.
Thank you. This was fun, Kevin.
Absolutely. And with that, we are going to wrap up for tonight. Rick has already given his outro slide. If you want to get a hold of him, you folks know how to do it. If not, go back and watch the VOD, and then you'll be able to see. So with this, we're going to wrap up. We'll talk to you again in the month of August. So quick reminder, second Tuesday of the month will be the Advanced DBA session. Third Tuesday, main meeting. Fourth Tuesday, data science and business intelligence. And in the meantime, there will be a Shop Talk episode next Monday. So with that, everybody take care, and we'll see you later.
Goodbye, everybody.